that we take the whole number, for instance, the whole number here, convert that whole number to base 2. Afterwards, then after the decimal point, that number there to be converted to base 2. Is that okay? So how do we convert this one to base 2? Even this one calculator can just give us the base 2. Those who know the calculator well, we can convert this one to base 2. That negative 57. No, the negative is nothing here. Just convert 57 to base 2. After you add a negative sign to the, whatever you get. So what will be 57 to base 2 to be what? 1 1 0 0 like this. Okay, so it's negative. Okay, so the negative here doesn't have any influence on converting numbers to base 2. Doesn't have any influence. So after that, after the decimal point, what we have here, so this one can be written as 0.1. Is that okay? Because we have already converted the 57. So what is left here is 0.1. It's 0.1. So we can write 0.1. What you do is that you multiply it by 2. Is that okay? So multiply 0.1 by 2, you get what? 0.1. 0. Is that okay? Since this number is still not in base 2, we continue. Is that okay? So you take 0.2, you multiply by what? 2. You write the results, you get what? 0.4. Is that okay? So since this one too is not in base 2, please when something is in base 2, it means that the number is lesser than 2. Below what? 2. So it's, we continue multiplying this one by what? 2. So 0.4 times what? You are getting 0.1. Please, you do it till you see some pattern. That is why in one people I'm reviewing course now, we're in level 200. That is methods of teaching junior high mathematics. You see, we're doing some patterns. We draw a triangle and you ask it to find how many triangles are in that sequence and series, how to form a series and a sequence. The same thing, you do it so you find a certain pattern. If it is repeated, let me tell you one thing, since these things are even numbers, there is no way that you have an end. It will continue and repeat itself. So do it so you get a pattern where it is repeating. So we are here 0.8. This number is still the 0.8 here is not still in base 2. So we continue again. Multiply the 0.8 by what? 2. So when you multiply, you get what? Are you okay? You can see that we are not interested in the number here, we are interested after the decimal point. What's the number there? The number is 6. And that number is also not in base what? But this one is in base 2. So what do you do? 0.6, then you multiply by what? What do we get? 1.2. Is that okay? So the 2 is not in base 2. Is that clear? It's in base 3. So what do? You multiply 0.2 by, what are you getting? 0.1. Can you stop here? So we have not have seen any pattern here. Yes. Let's continue to see. And continue small. Certain that it may change. So 0.4 times what? What are you getting? 0.8. Then 0.8 times 2. What are you getting? 1 point. So what can we see over here? You can see that it's repeating 0.0011. 0.0011. So let's continue. 0.6 times 2. What are we getting? 1.1. You see it repeats. Go back to 0. 0.2 times 2. We are getting 0.1. Are you okay? So you see when you got here, we get 1100. 1100. It will repeat that, so we will not get the end of it. So when you get to this point, we can end here. So what do we mean over here? We mean that from this side, these numbers are the numbers that we are looking for in base 2 over here. So that 0.1 here in base 2 is this 00011 0011 Please, are you okay? Please, are you okay? Who is not okay here? Okay. You see, when you are giving this to convert to base 2, what we do is that we take the whole number part, just convert it. Afterwards, at the next number, the number that is there, you also convert that number to base 2. So how do you do it? You multiply that number by 2. So when you multiply by 2, write the result. So the result that you have written, after the decimal point, the number that is the actual sum is the number in base 2. It's called in base 2. You take it and you multiply by the 2 again. Now the rest of my number that is there, check it again. Is it in base 2? If no, take it and multiply by 2. You do it so the number gets to what? Base 2. Lesser than 2. Are you okay? So after doing it like this, these numbers are not what we are looking for. But the numbers here is what we are looking for. So please, you don't start from the bottom to the up, but you start from the up to what? Downwards. Here, after the decimal point, you have to write those numbers. We start from the up here downwards. You don't start from the down. If it was a whole number, we start from the down to what? Up. Is that okay? So we start from this point, then you write it to this point. So we can say that negative 57.1 in base 2 is equal to negative 111,001 points. Then you start from here. You have what? 0, 0, 0. 001. Please, I can't continue again. So this is what we do. You put a bar here, showing that the 001 is repeated. Is that okay? These things are very, very important when it comes to floating a point. So if you are floating a point and you don't know where the number it is repeated, because some of the precision or the estimate that we have to get must be 32 numbers. And we have the double, then we have the single, and then we have the extended one. The single takes how many numbers? 32. 32. Yeah. Yes. So I hope you know that. The single takes 32, while the double takes what? 64. And the other extended one takes what? 8. But in the examination, Madam asked us to send this one to 32. A single one. The single precision. So please, you know the number that is in this. So you have to add the maximum numbers to get to that 32. So in fact, if you have to write this one, we are going to repeat this one until we get the 32. Exactly. So if you don't know where this one is starting from, and you make a mistake and start from 011, whatever you get is wrong. So know where it is terminated. It is starting from 001. It's repeating from 001, 001. And you add till you get maybe the 32 digits that we are looking for. That is a single precision. Is that okay? That is it. So please, if you are having any decimal numbers in this one to compare to base 2, this is how we go about it. Just compare the whole number part first. Afterwards, you take the next number is multiplied by 2. So you get the number in base what? 2. Is that clear? So that is it. We saw so many examples the last time. Let me give this one before. Compare this one. Let me see before we start with we go with this one. Negative 5.75 to base 3. So let's take this negative 5.75 to base 3. So change the 5 to base 3. So after we concentrate on the 75, that's 0.75. Yeah. So let's convert this one. Yes, please. So if it has finished, so you see the number here is already in base 2. So yes. Negative, but what do we get for this? 101. 101. So the 5 will give us 101, right? So the rest of the numbers we have 0.75. Is that okay? We have taken the 5, so we are left with 0.75. So multiply that one by 2. What do we get? 1 point. Is that okay? Then the 5 here, is it in base 2? No. So you take 0.5. Then you multiply by what? So 0.5 times this will give us what? 1.36. This one is already in base 2. So you stop. You see, this one has an end. It will not reoccur as the one that we did. So we stop. So we start from here, then you write it. So that negative 5.75 is equal to negative 101 point. That is all. Please, are you okay? So that is it. So if you have to convert this is that equal. So practice your hands on it. Madam, anytime that you have a question, she will bring this type of question for you to answer. And it's a bonus for you. In the final lessons, you have to get this right. So let's look at the main problem here. That is a floating of points number. You see, in order to float a point, we have 3. Please also arrive the next area so that we all go at the same pace. So if I have to float a point, it must consist of 3 parts. And the first one is what? The sign. We need a sign. We need the exponent. And the last one is what? The mantiza. Please, are you okay? So these are the basic things that you need in order to float a point. First of all, when you get the question like this, if you have to float this point, this number, in a single precision, what you have to do is that you check the sign. So if the sign here, what the sign is it positive or negative? Negative. So if the sign is negative, what do you start with? 1. Positive 1. So when it is positive, you start with what? 0. Is that okay? So these are the very things that we must take. You must consider first. Look at the sign. Is the sign positive or negative? If it is positive, we go with what? Positive and negative, and we start with 0. But when it is negative, we start with what? 1. Is that okay? These are the things because we don't have time to count these things. You look at the first thing before you look at the one that is terminating. You never give the one that will end like this. These things are just basis. So always things that will confuse you more, that will let you work more. See, it will terminate down where to go is a problem. So we have to take this one into consideration. So after that, after knowing the sign, the next one is the what? The exponent. And where do we get the exponent? You see, after getting this number to be this, we must write this number in a standard form. Is that okay? We write this number in a standard decimal point is there, so you try to move the decimal point at least a 1 before the other number. So you move it backwards, then you multiply by, since it's in base 2, you multiply by what? 2 to the power something. So the many times that you move, here you are going to move how many times? 2 times. So here to the power what? Is that clear? And this is very important. This 2 is very important. Because it is helping us to find a certain thing. That we have a constant number here. That's 1, 2, what? 7. So whatever you get, you add it to this. The power, you add the power to this. So the power here is what? So you add the 2 to this. So whatever you get, 129. That this number to you convert this number to what? Base 2. Please, are you okay? So I said that the first thing that we have to do is to find the sign. Look at the expressions well. Is the sign attached to it positive or negative? If it is negative, we start from 1. If it is positive, we start from what? 0. So after indicating or differentiating or knowing the sign, you go to the exponent. The exponent is found by it's 127 plus a certain power. But what is the power? We don't know the power. To get the power, we must convert this number to base 2 first. That is why we have to learn this and before we can do the floating of points. So you convert this one to base 2, the answer that you get, you make sure the decimal point is here. So make sure that you run the decimal point to a number, not the last number, but getting to the last, at least one of it. So you move the decimal point to this side. So how many jump or how many steps are you moving? Then you multiply it by 2 here. In the standard form is 2 to the power n, whereby the n is the number of what? The steps that you move. So assuming that here, how many times are we 5 times? So it will be 2 times 2 to the power. So this 5 is the power that we are looking for. That will help us to find the exponent. So you add the 5 to 127. Exactly. This 127 here is what? Constant. It's constant everywhere. So you add the power to this. So whatever you get, then you convert that number to base 2. Please, are you okay? Please, are you okay with it? Yes. Very good. So that is it. So that is all about the how to write or convert or float a point number to a precision form. So we see that Madam gave a certain table that when you are asked to float a number, the single takes 22 digits and the
double takes 64.
The double takes 64 and the extended one takes 80. So these things is very, you must keep these things in your mind. You must keep these things in your mind. I don't think it will be advisable that you give you that double. Always is the single one. The single one, because the 64 when you small your book, it will go it's not about 3 lines or 4 lines. So whatever you are doing, you have to count that you get that 64. You count them, you count them, you count them before you get what? The 64 legacy that you want. Please, are you okay? So please, in order to write this one, so let's take example. And let's try to write this one in this. So let's maintain the same example here. We are trying to write this one as a floating point. This negative 57.1, we are trying to write this one in what? In a single precision form. Then the question will not be like, just write this one in a single precision form. You like to float this point. That is the question. Float 57.1 as a floating point number. That is the question. So you know how to do it. Send it to a single precision form. That is 32 digits. Please, are you okay? That is what you have to do. So don't wait for anything for somebody to tell you that it's a single precision before you do it. No. As soon as he tells you that float the point, please base your workings on what? The single one. So first of all, ask yourself, the sign is what? What is the sign? The sign is what? Negative. So what will be the actual sign? The value of the sign will be what? The sign, therefore, is equal to 1. Please, you must take this one before you do it. Then you go to the exponent. The exponent, please, what do we get for this? We got negative 111,001 point what? Please tell me the answer. 000. Like this. Please, are you okay? So please, let's write this one in base 2 first. Let's write this one in a standard form. So we will get what? 1.11001001100. Please, are you okay? Times 2 exponents. Please, are you okay? So, and to find the exponent is 127 plus the power. Is that okay? And the power here is what? Is 5. So it's 127 plus, which gives us 130 what? So let's convert this 132 in base what? 2. Is that okay? So whatever you get here, then you convert the number here, the exponent that you get, convert it to base 2. In floating numbers, our concentration is to work in base 2. So you make sure that this 132 here should be converted to base 2. Please, and this converting of this number to base 2, we don't like the actual one, that is the kg one, that where you draw a table and we are not interested in that. So if you know the calculator, you just find this one and convert to base 2 and write the results. But what we need is to convert this one to base 2. So just input this one in the calculator, you go somewhere, shift plus something, to give you the number. You get what? 100. How many zeros? Is it 4 zeros? 1 base. So now another 0 to it.
Another 0. 2 zeros.
Like this.
Yes.
Okay. So after this, we are almost done. But how do we write this one fully? How to write this one fully is the problem now. So please, this is how we do it. The sign must come first before the exponent, and the multiplier should follow. So we are the sign to the what? 1. Then we go with the exponent. Then the rest of it, then we come to this place. This place. After the decimal, when we converted this one to base, the standard form, we start from here. Then you write it to this point. Before you get the 32, look at where it is terminating. Then you repeat the numbers, you count till you get what? The 32 digit numbers. Please, are you okay?
Yeah.
So this one, so since the sign is negative, we start with what? 1. Please, let's watch here. Then we continue with the exponent. So we add 1, 0, 0, 0, 0, 0. 1, 0. Please, are you okay? Then we come back to. Please, are you okay? Where we converted the number to base 2, to the standard form. So it starts from here. Please, this one is not important. After the decimal point, the numbers now watching now, then you write all. After the decimal point, so it's 1, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0. Is that okay? The zeros. The beginning. So it's 5 wrong. Okay, sorry. Thank you very much. So please, this is repeatable. But so far, how many numbers do I have here? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. We are not up to 32. So that comes the problem. What should we add to get the 32? Supposing that it is not terminating, it's not repeating, just add 0, 0 before you get 32. But here, this 0, 0, 1, 1 is what? Repeating. So we have to repeat that till we get what? The 32. Is that okay? So we repeat 0, 0, 1, 1. You have to repeat again. So how many have you gotten? This is 27. We have not ended. 0, 0, 1, 1. We are getting 31. 0. You see where it is ending? 0. So if you are not careful and you write here 1, it's wrong. So let's count. If you count them, you must get 32. So when you are marking this, they look at this and this. The first one and the last one. So they can really determine that this person is wrong. So when you count down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So that was a very nice one that came to our examination, and it was very simple. So that's how to float this point. Let me take another question. Let's float this one. 53.7. Let's convert this one to a floating point. Convert 53.7 to a floating point number. Please. So the first thing that you have to do is you can just write the sign first. So here the sign is what? 0. Sign equals 0 for the first one. So the second one, we need the exponent. But before you can get the exponent, you must convert this number to what? Base 2. So that comes from, that's where we have to start with the base 2 first before we come to this place. So let's convert that 53.7 to base 2. So you do it for me, then you tell me the answer. So compare the 53 first, 53 first before the 0.7. 0.1. So the 0.7. We get 1.4. 0.4 times 2. 0.8. That one too is separating it. It's not amazing. It's not amazing. So get 0.1.1. 1.6. It's an even number. As long as you see an even number, it will never end.
Are you continue?
It will continue.
Are you continue?
So 0.2 times 0.1. So what do you see?
You see 1 0 See, it is repeated by nothing. Zero.
So you see, I get 0011. 0011. 0011. Count it.
Yes.
Like the one that we did.
No, this one.
Please, if you can see from where I ended, you can continue so that you see the pattern well. Really, okay. Please, where maybe I will end, you can't see from there that it's repeated. But you can continue to see where it is repeated. Exactly. There is not anything. You can continue. Continue by the time. So here, from here, we can say that my 53.7 is equal to 1100 101 point what? 1 0 1 1 0 0 0 0. Is are you okay? The distance, if you can't see it, you continue. Continue. You can see that. You see here, there is not tabulated, but it starts from here. 0 0 1 1. If I do it again, the next number will be 0. I'll get 1 1 again. 0 0 1 1 again. It will pause. It will never end. It will continue to wake up again. So, in writing this one to the standard form, we get 1.1010 10110011 times 2 to the power
6.
This 6 or 5?
5. Open your eyes.
It's opening your eyes well. Yes. 5. So we know that the exponent is equal to what?
127 plus 5.
So my exponent here, 127 plus the power. So 127 plus, which gives me 130 what? 2. So 132, we have already converted it. I didn't know it was 5. I should have changed it. So this one to base 2 will be 100000100. So when you compare this one, you get this. One thing about numerical analysis is that it is not difficult, but if the calculator work is poor, you get everything wrong. Yeah, because the numbers that we are dealing with is what do we call it? Decimal numbers. Decimal numbers in Quran. So if you are not competent with the calculator, you get the answers wrong. That is the main. So whenever you are doing this, you have to be very careful. Accuracy. As I was saying, numerical analysis. Every subject, there are other analysis to it. It's not a small course. Every course there with analysis. It's not a small course. Intro analysis, you know how we solve it before you are able to pass. And now we are doing what? Abstract. Then go to the one, we got something VA, vector analysis. You see, things analysis, they are not easy. Analysis, you are not getting the results. They will figures, vectors. So let's continue from here. Please, as far as we do this, we are almost done. So please, here the sign was what? 0. Let the sign count first. Please, as some of us know from JHS, if you have a number and 0 is beginning, this 0 is not passed, so you don't write them. Please, here we write the 0. This is clear. You said that when we have 27, it is same as 027, but because the 0 doesn't have any effect on the number, we don't write them. But here, it's compulsory. It's compulsory. So we start with the 0 first. Then the next one that you have to write is what? The exponent. So it we start from the bottom to it. So 1 0 0 0 0 1 0 0. Is that okay? Then we come back to after the decimal point. What are the numbers here? 1. That's the mantism. 1 0 1 0 1 1 0 1 1 0 0 1 1. These are repeated. 0 0 1 1 is repeating. So far, how many have you gotten? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22. So we need extra 10. So we repeat 0 0 1 1 0 0 1 1 0 0. Count them and see if they are not out to 32. You know how I did it? Because these are 4. I'll repeat, these are 4 numbers. So if I repeat 2 of them, I repeat the second 2. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So please, so yeah, it's ending 0, 0. So please, whatever you are doing, please shine your eyes well. Do it well. Let us see. But you start from 0. So assuming that it was negative, you should have start from what? 1. But since it is positive, you start from 0.
That's what
Are you okay? Yes, please. If the power is what? And like you move the power this way, that one there, I've never come across that question before. That when it is negative. We have never seen those instances before. Because always, if we have a number like this, we automatically get to something like this. And the decimal number, the decimal will come in between numbers, and you must write it in a standard form. Do you get what I'm saying? So look at this number, that 53.7. You see, after this, you got this. So the decimal point will come here. Then the other after the decimal point, the number that is there converted to what? Base 2. So when you convert to base 2, automatically the decimal point will be in between that. It will never come before the numbers. Like you will never get 0.00 something whereby you have to get a negative exponent. Is that clear? You see, when you are moving like this, it is negative. But when you are going like this, it's positive. Is that okay? So I don't think there will be that instance. But if that is the case, you can put it there. So when we have a negative, 1 time is minus 2. So the answer you get just converts to base 2. But I don't think that's why I don't want to use that explanation. Please, then if you are happy, let's try this. The last one, let's all do it. This one I will not do it. You do it, then we continue. Let's convert 42.8 75 Let's convert this one to a floating point. 42.875. Please, we are moving small because after here where we are going to differentiation and integration. That is the numerical integration and differentiation. Or by this place, we are moving on to a very serious zone. These are bases. Let you have a pamphlet. So the lesson is very clear. So let's quote this number. 42.875 to a floating point. They have to finish with the discrete function, backwards divided into the central and the continuous. So let's hurry up because I have to go there. Please, are you done? 42, what did you get? You get like 75. So I'm getting the 5. This one has an end, so it's 1.010. But this one does not repeat. It does not repeat. So please, this one, then you add zeros, so you get what? The 32. So after writing the mantisa, the rest of them should be what? 0, 0, 0, 0, till you get what? The 32 restrictions. Oh, please, I hope we are okay with it. But the sign should be, it's positive, so it should be what? It's 0. So we start from 0. I didn't count them. So add the zeros, so you get what? 32. Please, are we okay with it?